And here we go. We have liftoff.
Propulsion continues to be normal.
R68 chamber pressure looks good.
Following up. Roger, roll, Atlantis.
Water towers fly! Yes!
Tango down to nominal.
Flight downside FTS off. Bring in FTS off. It's orange!
25! Oh my god! Oh my god!
Decollage.
What is it?
Put that in the big bag, you know.
343 unfolds to go.
Indeed.
We rise together, back to the moon and beyond.
The methane would be igniting in the flare, correct?
Yikes. You dead? Sure. We don't need any more of these.
Good afternoon. This is Lon Seidman from NSF. Thank you all for joining us for Countdown to Launch. This is our semi-regular show where we look at the progress being made towards launching Starship for its first orbital flight test, or maybe the second one, given the first one wasn't as successful as they had hoped. And there's a lot of hype around this, a lot of anticipation, and a lot of things happening over at Starbase in Texas, where we've been keeping a very close eye on things. And if our camera can switch over there real quick, you'll note that the rocket has been destacked. So we definitely won't see a launch today, but we hope to see one in the near future. We've got some developments in that area. Joining me today is Trevor Sesnick, one of our experts here at NSF. How you doing, Trevor?
I'm doing great. Thanks for having me on.
Thanks for being here to help answer everyone's questions. And also joining us is Alex Romero. How you doing, Alex?
I'm doing fantastic.
And
It is. I guess it is. It should be called hold down to launch because right now they are destacked, right? So it's like, yeah.
yeah, let's talk about that. So we had a stacked rocket. There was a lot of excitement that, hey, maybe it's stacked for launch. It was certainly staying stacked for the better part of a week and a half or so. What's going on? Why do you think they destacked it?
Well, a destack was not sort of not unexpected in the sense that we were expecting this to happen. The thing is, we were probably expecting it to happen closer to the launch than this time around. And so actually, a lot of people were saying, hey, this is a destack for FTS, for the flight termination system. And we sort of explained this in the past few times where we go live, that in order to be able to basically configure the flight termination system, they need to destack the vehicle. The flight termination system on ship 25 on the ship up top, it is sort of in the middle of the vehicle. So you have a 20-meter tall orbital launch mount, you have a 70-meter tall booster, and then you have at least 25, 30 meters up to the flight termination system box. So you have way over 100 meters to go. And I believe the tallest lifts are something like 90, 100 meters. So you have to still go like 30 meters more than that to get to that point. And so it is very complicated. There's no way to actually do that unless you have to destack the vehicles. So it is not unexpected in that sense. But again, we were not expecting this to happen this early. The reason why I say that is because in recent days, basically since Wednesday, the last time that we were live for this Countdown to Launch series, where the FAA acting administrator was talking about the licensing process and how they were doing with the SpaceX, and that it might take until early next month, maybe a little bit later, but they were positive that it will be occurring within the next few weeks, and so that puts us at least 2 or 3 weeks to that licensing process to be finished. And precisely, I think it was yesterday, Kathy Lueders, now working at a SpaceX, she precisely talked about that as well. We might hear about that a little bit later and things like that. But definitely, she also talked about that 2-3 weeks time frame that the FAA acting administrator was also talking about. So it seems like both are in tune, so to speak, on when these sort of schedules might happen. And definitely, if it is 2 or 3 weeks away, why are they doing all of this? Well, precisely, Kathy talked about doing other work as well. It is not just the FTS, it is not just the flight termination system, even though they have to configure it, but it is not just that. They also have to look through all of the vehicles, make final checkouts. in essence, they'll fly when they're ready to go, both from a vehicle standpoint and regulatory standpoint.
And Kathy Luters is the woman in charge, I believe, Trevor, of Starbase, or at least making sure the flow of activities there happens efficiently. And she was speaking to a group about that, where she gave that 2 or 3 week number. She also had some pretty important roles inside of NASA too, didn't she?
Yeah, so she had a bunch of different important positions at NASA, and I think you can give a lot of credit of the success of the Commercial Crew Program to her and her work on Dragon and with the SpaceX teams and NASA teams and Starliner teams. And then later she got promoted to, I think, like head of human spaceflight or some equivalent title. And then she left NASA for SpaceX and is now the head of Starbase, I believe is her official title, something like that.
So she's going to be making sure all the starships keep running on time down there. And we saw them, of course, destack the rocket. Trevor, this is something that these rockets are designed to do, I guess, because normally when we look at a NASA rocket, they stack it and launch it. Destacking is often a very arduous process, usually resulting in rollbacks to the VAB, as we saw during the shuttle period. SpaceX can operate a lot more efficiently when they've got to destack something, it looks like.
Yeah, for sure. Right, the chopsticks have made it very easy for SpaceX to rapidly assemble their first and second stages of this vehicle, despite being so enormous. And like you said, with SLS or the space shuttle, what we often see is if they have to do any work to the vehicle, they have to roll the entire mobile launcher with SLS back to the vehicle assembly building, and then they can do whatever work. If they need to get somewhere high on the vehicle, they have the mobile work platforms that they can install, work on the vehicle, move those away, and then roll back out to the launch pad. Here, SpaceX has condensed a lot of that, and with this chopstick system and the not forklifts, the cherry lifts, we see that they're able to do a lot of work just on the pad. So yeah, it's not revolutionary, but definitely not something we've seen before for a vehicle this large.
It makes it more efficient. And Alex, one of the things I was thinking about as we hear them being able to do this work at the pad was when we were doing a similar watch of the Artemis 1 launch, and how NASA was describing that, well, there's some things we can do related to fuel at the pad. There's other things we have to do back at the VAB. How much do you think they can do at the pad versus having to roll their rockets back into their production facilities there?
At a Starbase, well, it is pretty much a whole thing with the lifts there, where they can work on the booster, but they cannot work on the ship. For example, they need to work on the ship basically when it is down on the ground, and so it is a thing where they need to destack. But unlike SLS or shuttle or any of the other rockets out there, I guess the only sort of close to that you can see is sort of the rockets that can go horizontal, such as Falcon 9 or Falcon Heavy, or even smaller ones like Electron and things like that, where you can put them horizontal, and then it is a very easy way to access the vehicle. Whereas these vertically integrated vehicles, like the shuttles, the SLS, you have Atlas, even, you need these sort of like access platforms and things like that. For Starship, they have an access platform. They have basically the QD arm that goes and basically plugs into the QD arm, and so this is something that only allows them to access that part of the vehicle, which is the umbilical section of the vehicle. But it doesn't let them access, because we've seen people saying, cannot they use the chopsticks to go and get to the flight termination system to be able to work on it or something like that. The geometry does not really allow that, unless you put some kind of extension that folds out or something. It will be much weirder. Overall, they still need to destack, but it is a much shorter process and faster process than SLS or anything like it.
Right, and I remember when I first visited the SpaceX facility at Cape Canaveral, back when they would let us crawl around inside the facility there. One of the things that really, I think, amazed a lot of people that were seeing the work being done there, especially 7, 8, 10 years ago, was that the Falcon 9 was completely horizontal for most of its prep work, where they could bring it in, actually just turn the rocket to get at what they needed to get at, and then they would roll it up and go vertical. And they still, of course, prepare Falcon 9 in that way. But Trevor, this rocket's just too big to work on like that, isn't it?
Yeah, and right, Falcon 9 has the advantage of being smaller, so taking it from being vertical to horizontal is significantly easier than with Starship. And with Starship, I suspect they'd have to add quite a bit of reinforcement throughout the tanks or whatever, just because they are not meant for loads horizontally. They're just meant for, right, obviously the outward pressure from the propellant in the tanks, and then uh, loads vertically through the vehicle. So it's definitely possible that eventually they could redesign these to be worked on horizontal, but I find it very unlikely that that will happen.
And it seems like they designed this pad to be able to very easily destack and restack. I'm guessing they don't want to probably do too many stacking and unstacking, because I'm sure there are parts that might wear out if they probably use them too many times like that. But I guess in some ways, this is a rocket designed for, actually always, a rocket designed for rapid reuse. So perhaps this is also a good test of that. Alex, how many destacks and restacks do you think we're going to see on this test article?
Well, hopefully this is the last destack that we see. Because my hope, at least, is that the next time that they stack the vehicles is actually for flight. We don't know, though. Precisely one of the comments that Kathy talked about was, doing checkouts. We don't know what sort of, because I saw one comment before where they were saying in chat, but Elon said the vehicles are ready and Starship is ready. It's not the ready that you think it is, because that's the point here, that it can be ready or ready, right? It's
Right.
that difference where, sure, the vehicles are ready, ish, right? It's like ish.
Right.
It's not entirely ready because they still need to do a lot of checkouts. Usually, these final few weeks, they are doing things like, what they are called flight readiness reviews and launch readiness reviews. The launch readiness review might actually come a little bit more closer to the launch, but usually these times is when they go through, they basically go through all the documentation, all of the paperwork that they themselves, because people think that all of the paperwork is just the FAA or the government. Oh yeah, SpaceX doesn't work with paperwork because they are, these startup company. They're not a startup company anymore, guys. These are serious professional engineers, a 12,000 employee company. They have all of this documentation about the vehicles, about all the systems. That is precisely what allows them to know what's going on with the vehicle, right? Like if they have a failure, then they have all of this documentation to back it up. Like we did this, we did that, and the other thing, right? And all of these long list of hardware and software and things like that. So that's what they have been probably doing, and they were like, look, we need to do a little bit more work because there's this little thing, this other little thing. We've also seen them doing work on the launch pad as well. Like even when Elon was saying we're ready to launch, they were still doing stuff on the pad, especially on the deluge tank farm, where they had removed that sort of pipe. That now it is back installed and everything. We think it is now configured for flight. Maybe it's kind of hard to actually gauge if that is the case or not. The proof will be if they do any sort of testing of that system. But definitely, the whole thing here is that it is ready to launch.
Right.
So there's still a few things.
And the vehicle could very well be ready, but all the other stuff that that supports the vehicle may not be. But Trevor, one of the things that I've been doing this week is reading the Elon Musk biography, and there was a lot in there, of course, about SpaceX's early days and how scrappy this team was, and how they were, in some cases, even adapting off-the-shelf air conditioning compressors to run on their rocket to keep certain things cool. I would say, though, Trevor, that the spirit of that scrappy startup is still kind of at play here. I don't know if somebody in the headquarters there thinks we disagree on this, but to Alex's point, where there's a little bit more procedure now, I still think there's probably a lot of that spirit of let's just push to launch and see what happens. What do you think?
No, I very much agree. I think it obviously is less than it used to be, partially because they're a way larger company and working on way more complex projects now. But the attitude is absolutely still there. Like we see that SpaceX has really changed the space industry and going from rockets have to work the first time perfectly and there's no room for failure, especially on something like shuttle that has crew on it, where that's absolutely the right way to design a rocket, to this idea where you accept some level of failure. Like SpaceX is perfectly willing to, as we've seen, blow up these Starship vehicles um, on flight tests or even during ground testing to get data from them to learn quicker. And to a lesser extent, we even still see this with Falcon 9, where even though they've landed 151 boosters in a row, they're willing to accept some level of failure with recovering boosters because they're able to learn more. And they've constantly risked some Falcon 9 boosters to increase the amount of data that they have. So I think SpaceX is in this really unique position where they have some programs like Dragon, which are like very typical NASA ways of going about things, where they have zero room for failure because there's a crew on board. Um, then they have like the middle ground, which is Falcon 9, where if there was a failure on a Starlink mission, it would be bad, but it wouldn't be the end of the program. They would be able to bounce back for it. And then there's Starship, where right now they're willing to, get tons of data. So it's definitely still that Wild West mentality, especially at Starbase.
And they're still fighting, of course, on the regulatory side. And one of the things that we learned this week was, in addition to the FAA certification or license that they have to get and be approved for, there's also, Alex, some involvement with the U.S. Fish and Wildlife Agency as well. Ross here was asking, what is the typical content of the required environmental approval for that? I'm not sure we know exactly what the U.S. Fish and Wildlife are going to be looking for, but I know they were very concerned with the extent of the debris that the first orbital flight test created, which was all that concrete that got blown out all over the place. And I know in the past there had been some concerns over the debris from the prior Starships that exploded all over the place as well. Do you think they're applying more scrutiny to this? And if they get the FAA license, will the U.S. Fish and Wildlife issue their approval at the same time? Because they can't launch without approval from both agencies, right? We're getting more and more federal regulation involved here.
Yeah, and it is sort of fair as well that they have this concern as well, and we sort of got this question whether, like, why is it even involved, and so we are not fully sure. That's the sort of answer here, but definitely one of the things from the environmental assessment that was released on 2022 was precisely that after a mishap, after an anomaly, all of the debris and things like that, SpaceX needs to coordinate, and like SpaceX themselves, they were saying on the document, we are going to be in charge of getting rid of all of this debris and everything, and being able to eventually tell the environmental agencies involved in this process that, hey, it is all ready to go for the next launch. It is pretty much all basically in concordance with whatever they had already planned back then. And we also kind of forget that for the first flight, for example, they did sort of a review of the review, where they looked through the profile of the first flight, and they were like, okay, how does this change things compared to what we did on the environmental assessment last year? And so they had, I think it was like 50 pages on things like what are the differences of this flight in terms of how it affects the nearby refuge and things like that. How does it affect the splashdown of the booster, for example, on the marine life, or like if there's any contaminants. And overall, it was like it's actually shorter, way shorter than the environmental assessment, because it was only focused on the first flight, and we got a ton of information out of it because that was made public. We knew about the profile of the flight. We knew about what was going to be the fate of the booster. There were talks about even punching holes on it, because the idea was that just let it sink, let it be, open the vents or punch a hole in it, but they were not going to be recovering it. And so all of these details, where they were sort of, saying, okay, all of these things, we were not really covering it entirely in detail on this environmental assessment, so now we're covering it. For the second flight, I will not be surprised if we see something like this, maybe to a lower scale, because the profile is going to be pretty much the same. It's probably going to have the booster landing on the Gulf, in nominal conditions, obviously. And then the ship also going all the way to Hawaii, being, the hard splash down to the ground. They have like 10, 20 pages just on how the ship will explode, impacting the ocean. They had this detailed very, very well and very well studied to make sure that all of these impacts to the environment were properly accounted for. And overall, what they said, it's okay. It's not really that. I mean, there's impacts obviously, but they're not huge impacts on the overall scheme of things. And so I can see the same thing here, where they're taking a little bit of time and maybe doing this as well for the second flight. And I'm not going to be against that, because if we get sort of that, all that documentation out, then we're going to see a lot of details about the second flight. So silver linings, guys.
Silver linings. And I think, too, that part of the FAA license, when you look at some of the things they asked SpaceX to repair and fix based on what limited information we saw from what SpaceX released, you can make the argument that certainly the water deluge system was there to prevent some of that concrete from making its way into the local environment. So I have no doubt that U.S. Fish and Wildlife's concerns are integrated into the launch license, and I think we might see a very quick approval on both agencies, because I would imagine a lot of the concerns that U.S. Fish and Wildlife had were part of the FAA's concerns, because ultimately that's an impact on the ground related to health and safety and environmental issues. So we'll see where this goes. But I think if Kathy Luters is saying 2 or 3 weeks, that might very well kind of be what we see here. Another thing of interest was that Elon Musk was in D.C. just the other day, I think yesterday or the day before, for a summit on AI with the Congress and with a number of other tech CEOs. And in the outside, he did like a little press availability on the sidewalk, and he was rushing to get into his Model Y there, Model X, to go to the FAA to meet with them in person. So there's definitely some discussions happening at the top. And I would imagine that Elon was probably meeting with some of the people at the top at the FAA as well. And certainly the government has an interest in getting this rocket off the ground so we can get to Artemis 3. So go ahead, Alex.
And that's a very normal thing to see, because people, there's this whole partisan politics and things like that. That is a normal thing to see Elon actually going out or even calling the FAA or things like that. People forget that in the Starhopper era, we spent like a month waiting on the FAA to approve Starhopper's launch. And you can even go back and see Elon's tweets talking about, oh, I'm calling the FAA tonight. Oh, I just had a call with the, like every few days he was calling the FAA trying to get that approved. And that was 2019. That was with the previous administration. That was not even this. So look, this is just a thing that happens all the time. There are regulations that have actually changed with this administration as well. So it's like, these are things that go across the aisle, as they say, right? And so it is not any weird thing. This is something that all of the companies have to go through at the end of the day. This is not just a SpaceX. This is also ULA, Relativity. ABL had to wait for another month as well for their launch license when they were launching their RS-1 vehicle. I think it was like last year or something. So look, the government is just slow. You cannot expect them to be fast. That's the whole deal.
So
it's slow and cautious. Go ahead, Trevor.
On this, when we're talking about FAA, I do think it's very much worth noting that we at NSF have reached out both to SpaceX for comments regarding status of the launch license and whether they've applied for a modification or not. We have not heard back from SpaceX. And then we have had communication with the FAA, which Doss talked about a lot in his video. And we've since asked if perhaps we were overanalyzing when the FAA said that SpaceX had, or when they implied that SpaceX had not applied for the launch modification yet, and we have heard back from them saying that we have to reach out to SpaceX for comments. So we're kind of in this weird loop of not super knowing what's going on. And keep in mind that a lot of this is standard for the FAA. And they'll just say, we don't have any updates for now, please, or we'll make an announcement when the investigation or whatever is complete. And we've seen that the FAA has closed the investigation report. So we're kind of in this weird limbo. yeah, it's just a really weird situation, but I want to emphasize that SpaceX is working together with the FAA on this, and when they come to an agreement that SpaceX is able to launch safely, is when we will see SpaceX get their launch license modification and have the ability to launch. But it's very important that both teams agree that they can do it safely.
Exactly. And I think also what happens in this, we talked about this the last time I was hosting the show on Monday, is that a lot of this process is closed to the public for two reasons. One is that you have SpaceX's corporate secrets, and part of the agreement that the government has with these commercial launch providers is that they're not going to breach that confidentiality because there are competitive issues there, because SpaceX certainly doesn't want their competitors seeing some of the secret sauce that goes into their rockets, and a lot of this regulatory process dives deep into this. That's why when we see what SpaceX released in regards to the 57 different items they were working on, those all often had a certain sensor or a certain valve or whatever, and not the specifics. And that's due to, first of all, the corporate secrecy issues, but there's also ITAR, which prevents the companies from releasing information that might be used by enemies of the United States. So there's two factors here, and the government is certainly not going to do more than offer what they can do publicly, which is the results of an FAA decision and anything that goes along with explaining that decision. SpaceX, of course, has a bit of an advantage in that they can release certain things if they are okay or not violating, but releasing some secrets that they're comfortable releasing to the public. That's on them, and that's why we saw SpaceX release that list. The FAA couldn't do it, but SpaceX could. And I think what we'll probably see is if things are going well, I predict we won't hear from Elon all that much about the FAA. I think if they hit an impasse, we might see Elon tweeting a little bit more to put some pressure on it. And Trevor, while we're waiting for them to restack this rocket, Khalid Zubi was wondering, this is actually a good question, because the longer they wait, the more Starships they are cranking out down there at Starbase, where they're not only launching rockets, but manufacturing them just a few miles away, if that. Are we looking at the potential here, if this drags on for too long, that they might swap out the Starship at the top of that booster?
Yeah, it's a really good question. And as you said, they're producing a lot of vehicles at Starbase. I believe at Starbase itself, we've seen through ship 32 in production, if I remember correctly. So it's a fair question of, 25 is an old ship, right? They have 25, 26, 28, then 29, 30, 31, 32, somewhere in the works. So why are they using such an old vehicle? And the answer to that, as you imply in your question, is very much that the point of this test flight is for SpaceX to test the booster. And they want to just make it to stage separation, and that would be a huge win for them. Anything beyond that is really just kind of a win. So if they're able to get through booster flight and through stage separation and get data on how the ship performs, then that's the cherry on top, and they'll use that data for future ship design. But if they don't get that far, they would much rather lose an older ship that, as you say, doesn't have a lot of the upgrades than lose their brand new ship that has a bunch of upgrades. So on the next test flight, it'll be interesting to see what vehicle SpaceX decides to fly, because the current thought is it'll be Booster 10, and then if this flight with Booster 9 goes well, it'll probably be Ship 28 with the newer upgrades, and if this flight doesn't go well, then it will probably be Ship 26, which we've seen rolled out to the suborbital launch site.
Right, and Alex, that Ship
Well,
26
also-
is on the test stand, right?
Correct.
Yeah, so that is precisely the thing here, that the comment was talking precisely about why don't they launch a more advanced vehicle. The issue there, apart from all of the stuff that Trevor talked about, which I agree with completely, that it is mostly about the booster, is not about the ship. The ship is sort of like an extra nice thing to have right now, very early on. But apart from that, it's also that there's no vehicle right now, there's no ship right now out there that is in such an advanced state of readiness for launch as Ship 25. Basically, we have Ship 26 right now. It is right there on the suborbital pad B. You see both the difference between Ship 26, the one without tiles and flaps and everything, and then Ship 25 on the chopsticks. It doesn't have any of the sort of upgrades that we have seen on Ship 25 lately, before it rolled out to the launch pad for flight, we haven't seen. First of all, it hasn't completed any sort of static fire testing with its 6 engines. It has its 6 engines. We think it is out there precisely to do that testing, but it hasn't completed that yet. So they don't have all of these data. They don't have all of these upgrades, and so it will probably take at least another month or two to be able to put this vehicle in such a place where it could be launched. But even with that, then you go to Ship 28 at the Rocket Garden. That other vehicle is completely covered right now on scaffolding. It is pretty much not ready to go at any point. It does have its engines, but they're still working on it. It's still getting upgrades. We've seen in recent weeks it's getting some hardware on the nose cone, on other places as well. Like they're still doing some retrofits here and there of sort of upgrades that we've seen for future vehicles such as Ship 30, Ship 31. But definitely of the completed vehicles, Ship 25 is the only one that is the closest one to launch. Any other vehicle is months away from any sort of readiness for launch in any sort of way, either because it is missing upgrades or because it is missing testing or both. And so that's sort of the extra thing as well here, where it is Ship 25 just because of that, but also from what Trevor said, booster is right now the main thing.
And we're seeing, Ship 26 out there lacking any kind of ability to navigate through the atmosphere on the way back down, right? No, and we've been arguing about what we should call these things, but no fins on the side, no grid fins. There's no tiles, so this would very much, be a guaranteed destruction on the way back down. So there's just nothing else ready to fly for this flight test right now than Ship 25 there. So we'll keep an eye on it and see what happens. And one of the best things about what we do here at NSF is that the views that you see, these great camera views we have from Starbase, are coming from NSF cameras that are monitoring the facility from multiple angles 24/7. And we also have people watching those things so that when something interesting happens, we come on live and tell you about it. So we are certainly keeping an eye on things. We'll definitely be coming back with another stream when we do another stack. So that's going to be on the horizon as things move ahead. So we do this because we want to keep you all informed, of course, and we're able to do it because of the support that we get from everyone watching. And I've got a bunch of folks to thank in our supporter queue here. So Joel became a Capcom member. Thank you very much for that. Daniel Hamblin became a PadRat member, and that's the YouTube membership thing that you can see down below. You can click the join button there. Maxence H became a Red Team member, and we also had Jim Cavett gifting a Red Team membership. And one of our usual super chatters has a couple of questions here. I think one of them involves maybe a store update here. Musical Wolves is asking, how much longer will the concrete way to go be available? Do you know anything about that, gentlemen?
That's an Adrian question, right?
Yeah, we'll have to get the answer for that and get back to you on the next stream there, Musical Wolves. But also, though, this was another good question about whether or not the launch deluge system required a new environmental assessment. And I would imagine that any major construction that they're doing at Starbase would require probably both the local Texas environmental groups looking at it in addition to the federal. So I don't think they would be able to build something without getting some kind of environmental approval for it. And certainly when you have that much water being introduced to a small area all at once, that without question would involve some degree of regulatory approval prior to construction there. And another thing I wanted to bring up as we're talking about support is that we have a store at shop.nasaspaceflight.com, and there you will find the mission patch that our own Pauline designed for this launch that will be coming at some point in the near future. And you can head over to the shop right now and pick up that patch. It is a very high quality piece of space memorabilia that you can have forever. And one of the things I like to say is that if you were an astronaut flying on a rocket, this is like the quality of patch that they'd be putting on your uniform there. It looks great, very high resolution embroidery, and we have those logos for that mission patch on a lot of other merchandise as well, including things like pillows and mugs and all that other good stuff as well. So good stuff, and definitely check it out. There it is. Check it out in the store, and you can see the detail as we're scrolling through the page there. And you also have the opportunity when you're picking up one of these things to leave us a message, and those messages pop up here on our supporter queue as well. And don't forget, hey, look at that, you can check out right now. And don't forget, we're getting close to the holiday season. I like to remind people, have your friend or spouse or significant other, you put it on their computer screen in the morning and they just happen to see it and they get gift ideas for people like us who are very hard to shop for. So good stuff there. We also have some awesome metallic prints that you can get with some very nice detail of rockets launching, rocket parts, all sorts of good stuff from our photographers here at NSF, because we're more than just live streams and video. We do some great photography as well. So great stuff there. And Kyler Moneris wants to know, is there a Starlink 612 launch medal print? I don't know if there is one yet or not, but if there is, you can find it at shop.nasaspaceflight.com. So I want to thank everyone for their support of our efforts here. And as we continue to monitor activity down there, your support allows us to keep bringing you all of this great coverage. And there will be a lot to see in the coming weeks. And we're seeing a lot, right? Even with a stack and a destack, it's still giving us a lot of insight as to how this launch prep is going. And there's more going on, though, because don't forget, Artemis 3 depends on Starship, not only Starship launching for fueling purposes, but also Starship launching for the actual lander. And there was some work done this week, Trevor, towards the Raptor engine that will be used for landing on the moon. You want to tell us a little bit about that? It's called the Moon Condition Test.
Yeah, SpaceX tweeted 2 videos this week that were both very cool. The first was footage of a Raptor vacuum engine that had been chilled so that it was at the same temperature as if it had been coasting in space for a very long period of time. So I assume that they just chilled it with liquid oxygen and liquid methane for, significantly longer than normal to cool it down more. And then we saw just a very quick firing, I think it was under 10 seconds, of like they were igniting after that long coast. And that's obviously going to be useful not only for when you're traveling into lunar orbit, but also eventually into Martian orbit or just even to geostationary Earth orbit or something like that.
And Alex,
And
sorry, go ahead.
the other quick video that they tweeted was actually a very old video. We think it's from 2021.
Yeah, November 2021.
Yeah, November 2021, and it was a full duration burn of a descent burn from the moon. And what's a little bit unclear about this is this burn just the deorbit burn that Raptor will have to do to get the vehicle from some lunar orbit, then onto the suborbital trajectory to intersect with the ground? Or does this also include portions of the landing burn? And the wording that they use is very vague and very unclear. So it could be either deorbit or the final portion of the burn to land on the lunar surface. So I think the one interesting question that brings up is, right, the last we heard about the HLS lunar lander, it was going to have the thrusters higher up on the vehicle that it was going to land on and not rely on the Raptor engines. So if this was the landing burn, will we see those thrusters still? And it seems to me like the answer is probably not, that they'll end up landing on the lunar surface just with Raptor, but that is not confirmed by SpaceX or anything.
And that
And
video that you see there is
Yep.
the comparison. That is the one with a chilled engine that occurred
Mhm.
on August 25th. And we saw it on McGregor Live. So we were able to compare the test and be able to pull that out and do that comparison of how it looks from the SpaceX footage and from our own footage there. And yeah, that is
awesome.
I guess it's super cool.
Yeah, this is super cool, and literally super cool. Let me ask you this:
Yeah.
we're testing these engines for landing on the lunar surface on essentially the at sea level here on Earth, where you have obviously it not operating in vacuum. I'm sure they have a good understanding of how the engine should perform in a vacuum, but we have not seen a Starship get high enough to be in a total vacuum yet. What more testing do they have to do to be assured, Alex, that this is actually going to work in space after traveling to the moon for 2 or 3 days? or more?
Well, to work in a vacuum, that is easy in the sense that at the end of the day, it is not going to be that different when it is launching. The issue and the reason why they did this testing is that you launch and you go into deep space and whatever, and your ship might be doing different load cycles of temperatures and things like that. It is cold on one side, hot on another, all that stuff. It's gonna be, those engines are gonna be even colder than they already are. And on some of the footage that, on that same footage that SpaceX put out, you can see on the Raptor engine, that is a Raptor vacuum, but I assume that they might have been done something basically similar for a sea level Raptor. You can see there are cooling lines extra, like on top of the Raptor engine. They have already chilled down the engine even further than it is already chilled down, probably to make it be at the temperatures that you will expect in deep space. And all of the electronics on the rocket engine, on the metals themselves, all of that changes. And so when you go through that for several days and then you arrive at the moon and you need to light the engines again, you need to make sure that they're actually working again. Because the problem is not during launch that they're going to be working after stage separation or anything like that, because they have come from being at sea level like a few minutes before that, right? It's not going to be a huge change in temperature. The huge change is going to be when it needs to go out there to the launch to the moon, excuse me. And so it goes all the way to the moon, and then even there, it needs to wait for Orion to come by and dock and transfer the astronauts and everything. It's gonna stay there for weeks. So it then needs to light again the engines in order to come down and land on the moon. So these tests are crucial to test all of that.
Especially because you're depending on that on that rocket engine working properly to land on the moon safely.
Or even come back.
Even come back too. That's right. You have to get off the moon in addition to landing on it. So it just shows you how much farther we have to go here and how important we get to orbit first, at least, so that we can at least get the thing up there so we could even send it to the moon if we want. Hey, I want to thank a $50 tip that we got from Parker, who thanks us for the ever-evolving coverage team. And we are always evolving here and learning as we go. And that's what's been fun about this show, is that it's a great way to do some live news analysis with our experts here at NSF, but also getting in questions and feedback from viewers in real time. So you often see me looking down because I am monitoring the chat window here as everything is going on. And Parker's looking for a retro Starbase hat that might show up in the store. So I will pass that along to the management, who I also know is watching, and hopefully we'll see something like that. Usually they're pretty good about getting some new inventory in there for everybody to check out there. So we'll keep an eye on that. And related to what Alex was talking about, we got a few more supporters who we'll acknowledge in a minute or two. But I had something pop up here in my in the chat room. So if you hit at NASASpaceflight on the YouTube chat, that'll pop up in my window here. So we'll try to grab a few of these as we go, as we've been doing. Paul F. was wondering, getting this thing crew rated is going to take longer than they think for Artemis 3. And certainly we're launching Starships with nothing in them beyond just the ship itself. Getting a fully loaded lunar lander prepared and launched is a whole nother story. But Trevor, to some degree, this is a little different than having a human-rated launch vehicle, because humans, on Artemis 3 at least, are going to be launching on SLS and on the spacecraft that they'll be attaching to the top of that, which is, for some reason, escapes my memory here for the moment, because I'm getting, it's been a long week. But they will be launching on SLS and then transferring over to the lander. So are we looking at human rating being kind of a different definition here, because it's really a matter of being able to support a crew once it's already gotten into orbit, and the crew is not going to be launching on the lander that's going to the moon, if that question makes sense to you?
Yeah, no, this is a very interesting question, and I guess Alex and I are supposed to fight.
Here.
Yeah, right. Inadvertent bell again. Another experiment is our fight bell.
Yeah. So as you said, the crew for Artemis 3 and the other later missions are going to launch on SLS and the Orion spacecraft,
Orion
which is going to
spacecraft.
take it.
I didn't know what it was called. It's just been one of those days. Sorry, go ahead.
It's been a long week for all of
Yeah.
us.
Yes, it has.
Yeah, so then that will then dock to Starship in some lunar orbit, and then Starship will take the crew down to the lunar surface. So this does have some advantage, but also have some things that are more complex than, say, just Dragon. Obviously, the first thing is you don't have to create the heat shield, which is very good because I suspect that'll be the very hard part to crew rate. And then it also means that you don't have to crew rate super heavy, at least yet. Obviously, in the future, it will be. So that's two big components that will be removed. However, you of course have increased radiation you have to deal with. You're further away from Earth, so you have to have more life support and for a significantly larger volume. So there's those problems as well. And keep in mind that you still are launching on the vehicle. You're just launching from the lunar surface as opposed to the surface of the Earth, which is of course easier since gravity is what? I think a third of what it
1/6.
is on Earth. Is it a third or a sixth?
I think a third it is on Mars, and a sixth it is on the moon, I believe.
Okay, no matter what, it's
I think it is
significantly
that.
less.
Yeah.
So as to what this means for Artemis 3, I think that's a really good question. And it does seem like HLS probably will not be ready to land crew on the moon in time for 2026, I believe is when the mission is currently scheduled for. But it also seems like delays to other infrastructure for that launch will be delayed, such as to the SLS vehicle and Orion spacecraft. But if you want to learn more about that, read our articles on the news site by Philip Sloss. He's phenomenal, and you'll learn way more about it than I could ever tell you. So I think the one thing that NASA has commented is if the hardware is significantly far behind both Starship or SLS and Orion or the EVA suit for walking on the surface of the moon, they could change it to be just a crewed mission to the space station that's going to go into lunar orbit. But NASA hasn't talked too much about that plan because they really want that to be the first landing of humans on the moon in over 50 years. So
right, boots on the ground
hopefully
is a lot more attractive to the public than as cool as it is to reach a gateway, which will be in that Lagrange point between the Earth and the Moon. I think boots on the ground is probably what the public wants to see more than
absolutely
some orbital maneuvers there. Alex, what's your take on this? Because right, we're talking about a very complex mission profile here, made a little less complex given that we have Orion and SLS, which are already human rated for the most part. We're going to be testing that on Artemis 2. What do you think?
Boy,
there's the fight bell. We want to see some fireworks here. That's a real one right
well,
there.
that was a long answer. If I gave long answers, man, that was a long one from Trevor. But it's okay. I also give those as well. Yeah, I will say I sort of agree with Trevor that it is much easier when you don't have that booster in the mix, where you don't have the crew launching from the ground, and so you have it much easier. You only need to sort of crew rate the operations of the Starship, of the HLS, and so you have the crews basically from lunar orbit, because you don't even need to crew rate the the ship for the part where it's around the Earth or refueling. You don't need to crew rate a refueling, for example, right? Because if you have your people on board while you're sort of refueling the vehicle, that is very experimental to do that. It is even experimental already on the ground when you're trying to fuel a rocket. Imagine if you're doing that in orbit, right? Because that hasn't been done before in this scale, at least, or even with cryogenics at all. And so you don't need to crew rate any of that, because that occurs on low Earth orbit. That occurs way far away from the crew or anything like it. You go to the moon, you get your crew, and the only thing that involves the crew is just going down to the moon and go up again, and they stay there at the moon as well, where you probably want your vehicle to be able to survive the week, 2 weeks that you stay down there, the different illumination conditions, the sunlight, the power systems, and things like that. The EGLA system, basically the environmental control and life support systems and things like that. So overall, the only thing that the crew rating in this case needs to entail is just making sure that you can get to the ground, that it can then go up again into orbit, dock with Orion or the Gateway for Artemis 4, and then just basically make sure that in the meantime, all of your systems from software, the ECLS, all of that works basically according to plan. And how do you expect them to do? That basically is all trained through testing.
Right. And you think
I
about
guess
how
that's
much,
sort of the expression.
and you think about how much there is left to go insofar as what Starship needs to be in order to get this Artemis 3 mission going. Because on the surface, it sounds pretty simple. Put the thing up in orbit, dock it with Orion, land on
It's
the
very
moon,
complex.
get back up, and you're here. But somehow you got to figure out how to fuel this thing while it's up there. And so the mission profile, as I understand it, is that they're going to launch the lander into orbit. At that point,
The other way around.
Right. It'll be
First the depot. I don't even know how to pronounce this word because it's some French word.
Okay.
And so yeah, so that is first launch, and then they launch all of the tankers up there to refuel
so they're going to be up first, and then
exactly, and then the lander only goes up there and gets refueled once, because then it doesn't need to get all of these tankers. It's the last thing that they launch before they go to the moon with a lander. But definitely these
several, right?
Exactly, these sort of low Earth orbit propellant station that they're going to have refueled in orbit, and so you just need to launch the lander, refuel once. You don't need to wait around or anything like it, and go straight to the moon. And that is a really interesting format. Instead of, you launch the lander, and then you have to wait around for the tankers to come, and in between you're going to get boil off, you're going to get a lot of waiting time, you're going to get radiation hits on your software. Like, if you do it the last thing, that's a clever way to do it. And it works for Mars missions, because then these sort of propellant station, you can replicate that on multiple orbits.
Right, you can put them all over the place.
These things. Exactly. And you have 26 months between windows for Mars. That makes sense, right? That you have all of these propellant already stored in orbit. Then you go up there, launch the Mars ships, so to speak, right? Refuel them, go to Mars, and off you go. That is a clever thing to do.
And I think about, though, from a cost standpoint, Trevor, is that SpaceX is going to have to launch multiple fueling missions to that fueling depot to get those tanks filled up. If they don't have a reusable Starship, this is certainly going to go way over cost for them, because they were the low bidder on this whole project. And NASA, of course, holds SpaceX to, in most cases, and I'm assuming this one as well, into a fixed price contract. So do you think we need to see a fully functional, rapidly reusable Starship for Artemis 3 to happen?
Yeah, absolutely. Like you said, the HLS contract is fixed price, which is very exciting in my opinion, that the contracts, if you ignore SLS, to go back to the moon are fixed price. And that is just a really cool thing to say, and definitely would not have been possible without the commercial crew program and cargo resupply being so successful. And a lot of credit to that, in my opinion, goes to Kathy Leaders. So just huge shout out to Kathy Leaders, since we were talking about her earlier. But yes, absolutely, SpaceX will need to have a rapidly and fully reusable vehicle for these missions, because even if each Starship launch costs about what a commercial Falcon 9 launch costs, which is thought to be in the $50 to $100 million range, probably closer to 50 for most launches. To be fair, that's the customer cost, not SpaceX's cost.
Right.
That would just be very, very expensive, since we're probably looking at on the order of 10 or more refueling missions to get to lunar orbit. So if you're paying $500 million to just in fuel missions to get to the moon, then yeah, that's not a feasible program. But thankfully, it seems like Starship will be cheaper than that, and if Falcon 9 is anything to go by, it will not be too big of a problem, I suspect.
Right. So we have to get into orbit. We've got to get back down from orbit. We've got to rapidly reuse. We have to have all the life support systems. And there needs to be an elevator on this thing. So when it lands on the moon, you can actually get down because you're going to be pretty high up on that Starship, presumably at the top of it, to get going there. So there's a lot more to talk about here. Hey, Alex, here's a good question from Doug Martin with a $5 super chat. Will HLS use an airlock system for exit and entry, or are we going to be doing EVAs from one vehicle to the other?
It is going to have an airlock for basically to go to the moon. It even has it has two airlocks. So because it's so big that it can afford having not one but two of them on each side of the vehicle, we think. And so it's definitely a luxury lander, so to speak, compared to the Apollo lander. It's going to have these two airlocks. Exactly. Unlike, for example, the Apollo lander didn't have any airlock. You just had to depress the whole vehicle in order to get out of the hatch. For Starship, that's going to have two airlocks, two elevators. There's going to be redundancies all over the place because you have so much room that you are able to afford all of that weight penalty or volume penalty, whatever you want to call it, right? Because there's both volume and mass penalty here as well. But it's so big that you can already afford that. Two people inside of that vehicle, that's going to feel basically like a mansion on the moon, right? It's a what, 20-story tall vehicle on the moon. It's going to be a hotel kind of thing. You can see there, it's ginormous compared to
how are they going to get on it though? Are they going to have to? Are they going to dock Orion to this Starship lander, or is it going to require them to basically suit up and float from one to the other?
Yeah. So once they go into lunar orbit, then Orion comes. It launches on SLS. It's expensive, but it launches on SLS for now. And so it launches on SLS. It goes to the moon. For Artemis 3, it's going to dock directly with Starship. For Artemis 4, it is hoped that by then they're going to have the gateway. And so Starship is going to be already docked to Gateway. And so Orion will dock to Gateway, and basically the people will transfer through Gateway to the lander. But in the case of Artemis 3, it's going to be direct. So it's going to be from Orion to the lander, and it's going to be just from the hatches in between the docking systems. So it's not going to be any sort of Soyuz style where, if people remember the sort of lunar Soviet missions had the plan of having no hatch between the vehicles, and sort of the person, the cosmonaut, will have to do an EVA and hop from the Soyuz vehicle to the lander. It was a whole thing. That is not going to be needed. It's sort of like Apollo, where they had this hatch in between, this tunnel that allows them to go from the capsule all the way to the lander. This time, though, the lander is much bigger, so it has all of these redundancies. And again, for getting to the lunar surface, they have these hatches, these airlocks, excuse me, and it is not like Apollo, where they had to depress the whole lander to be able to exit the vehicle. So that is a very luxury thing to have these days, and I'm really on for it. Like, I'm all for it.
Yeah, eventually, you could have a whole crew of people, maybe half a dozen people, going in and out at will. It's almost like the era of the future that I was promised as a kid is finally starting to come true, and the plan for the future of this program, even Artemis 3 alone, it almost kind of sounds like a science fiction movie, but it's starting to kind of, I think, come into some reality here. So it should be pretty exciting. Trevor, what do you think we're going to be at by the time we get further on into this program? Because I see when you're at Cape Canaveral and Kennedy Space Center, you can see the 39B with the traditional cost plus rocket on one side, and then you turn to your right slightly to see 39A with this commercial, fixed cost kind of approach to doing this government mission. Which one do you think is going to win out? Because it looks like right now NASA is really dipping their toe in both waters, just to make sure they can still get to the moon in any way possible, irrespective of cost. But they're also toying with this new, cheaper, faster, better method that SpaceX has provided. Do you think it'll be a mix of the two, or do you think one is going to win out over the other?
Long term, I see absolutely no future for SLS. It is just way, way, way too expensive. And one fact that I love is that a single RS-25E engine that they're now producing again costs more than an entire expendable Falcon Heavy launch. And there are 4 of those on SLS. When and that's not even the most expensive part. You have the core stage, which I believe is on the order of $1 billion per flight, and then Orion is several billion. It's just way too expensive and is not sustainable at all. And even in the most recent report from NASA, the Inspector General report, they agreed that this is not a sustainable program.
It
Yeah.
So I
kills
think
me too
long
that there's
term, it's just going to be Starship and other commercial vehicles.
And it kills me too that that RS-25 engine, which was designed to be reusable, gets tossed out every flight. And I know Chris B, our faithful leader here, loves the shuttle, and I'm sure it must just hurt to see those shuttle engines, which were literally shuttle engines flying space shuttles into space back and forth multiple times. Got a nice upgrade, and they're going to get used once, and into the ocean they go for eternity. So it's quite sad there. Hey, before we close out, we've got a bunch of supporters here I want to thank. So we have Anonymous here with a store message, and I picked up some space swag while at work. So we won't tell your boss that. But if you're in aerospace, you can learn a lot, I think, from NSF, right? So there you go. Ryan picked up a patch for his collection. I can't wait for future patches. Much love to NSF and much love to you. And thank you for your support of everything that we do here. Here's a question to ponder from Flawed Perspective. Can HLS land on Elemental? Keep up the good work. So just flipping in a space joke there. Fabian also picked up some stuff at the store. Looking forward to the next 31 designs that we will have. And of course, there will be more to come because these are popular items there. Tom here with a store message. Greetings from Teacher Tom and his rocket science students on outschool.com, who are all big fans. So yes, we are, no pressure on us to be helping rocket science students learn about what's going on in space. And Amber with a $1.99 super chat. And we've got time for one last question here from Kyler, who was wondering, and we may have answered part of this, won't Starship's engines need to be chilled during liftoff? Actually, we didn't answer this question yet. Won't Starship engines need to be chilled during liftoff if SpaceX plans on separating booster and ship during an orbit?
During an abort.
On an abort, yes. I'm sorry, on an abort. It's Friday creeping
well,
in again.
That assumes two things: that the engines are not chilled down at liftoff, and that there's any sort of plans for an abort of the ship, of the boosters. So this is a long-standing thing where Elon mentioned a long while ago that probably cruise ships, when they launch a crew, they could have an abort system of sorts with the own ship engines, where they fire the engines if there's anything wrong happening with a booster, so they can escape and everything. That is one thing. And then another thing is the hot staging ring, because we've seen them installing that, and people are like, "Oh my gosh, that's gonna enable aborts, right?" Not quite. There's always very nuanced takes here, where it's like, first of all, you need a way to actually be able to have a thrust to weight ratio, basically the acceleration of the vehicle being higher than that of the pull of the vehicle. The weight needs to be less than the thrust. You need more thrust than what it weighs, because otherwise it's going to come down. And with 6 engines, even when you are on the pad, the thrust to weight ratio is not going to be like, it's if you do the math, depending on what sort of thrust numbers you take for the Raptor vacuums, because the only numbers that we have is for those engines in a vacuum, but if you fire them at sea level, it's a different number. Depending on what sort of thrust number you take, it is 0.9, 1.1, it is around 1. That's not gonna be useful for any sort of abort. You need something either that it's, it includes an extra 3 engines, which Elon has also talked about, but guess what? We haven't seen it either. That's the issue, that Elon talks about all of these future things, but we haven't seen it yet, and there's no really indication that it's coming up soon. And then you probably also need to underfuel the ship. And frankly, for crew missions, if you're going to low Earth orbit, that's not a huge deal to do. And he precisely talked about this as the solution for the abort system of a Starship, so to speak. Again, lots of air quotes here. But that was just sort of in the future, of something that could happen in the future. And the issue here is that this is not something that they have said, oh, the hot staging ring is precisely for aborts. It's just for stage separation. They're going to care about all of that abort and things like that way later down the line. It's not going to be something that is pressing matter right now. And the second item that I also wanted to hit, they actually chilled down the engines before liftoff. We saw for the first flight, they have these two vents on the sides of the ship that go down the side of the booster, and there are these huge vents coming down that are related with that engine chill vent. And I think that that actually begins sort of like 10 minutes before launch. The booster engines are a little bit earlier. They actually start chilling down them way much earlier in the countdown, but the ship engines start sort of like 10 minutes, I think, based on those vents and when we see those vents coming up. But yeah, those are chilled down before liftoff.
And just to give Trevor the last word here on human ratings, that was a question that came up earlier. NASA, of course, was very focused on escape systems for this next generation of human launch vehicles like Dragon, but also like Starliner, which I think is on your shirt there. Look at that.
It is on my sweater, yeah.
So do you think NASA would go back to a design that did not have a workable escape system?
Yeah, this really is the big question of, will NASA consider this safe enough? And I think what will ultimately come down to is, has SpaceX launched Starship a ton without any failures? Is right, the one way to easily get around the argument that maybe you should have an escape system is if you say, we've had 300 launches in a row without any problems. So that's kind of good for Starship, since they will need to launch it thousands of times for Starlink missions. But yeah, it'll be interesting to see what NASA wants to do in terms of crew rating Starship.
So we've got a long time to go, I think, before we've got all of these questions answered, both for Artemis 3, but also future human rating. But in the meantime, we're going to be keeping a constant watch on what's going on over at Starbase with all of the NSF cameras that are there. We've also got our cameras over at McGregor for all the Texas for all the testing that's going on, along with, of course, our cameras in Florida. Just keeping an eye on everything that's going on. And we're going to come back, and we have an ooh. What's the ooh, Alex?
Speaking of that, we have a launch tonight from Florida.
We do have a launch tonight. So tune in. What time?
Oh, wait. I have it here. At 11:38 p.m. Eastern Time.
And that is a Starlink mission, if I'm not mistaken.
In about 7 hours and 24 minutes. I have a countdown on my on my watch.
So you got
another
time
Starlink mission?
Another one. It's just
Starlink.
like it's the Starlink Express. They're going off all the time. So get have some dinner, get comfy, and join us back again later this evening for that. Before we go, I do have comment from Chris B in regards to my statement regarding the engines on the SLS. I was pontificating that perhaps he'd be unhappy with these engines going into the ocean after being reused so many times on shuttle. He's actually happy about it. He prefers that they go out in a blaze of glory versus being stared at by tourists. So I will give you that. And
we have breaking news.
Breaking news, Alex, go ahead.
Kind of breaking news. We have 2 road closures that are for transportation purposes, and they are for September 18th and September 19th. I believe we are today on 15th.
Monday and Tuesday.
So
okay,
that will be Monday and Tuesday, exactly, from 10 p.m. to 1 a.m. Central both. So that is a 3-hour rollout, which, if I'm not mistaken, might be related with a massive transport. So basically, SpaceX has this place where they cryogenically test vehicles out there. And right now, Booster 10 is at Massey's right now, and that those transportations from that place back to the production site or vice versa, they usually take about 3 hours. So these road closures being 3 hours long kind of point to that. Hopefully, cross fingers, and noggin boot and all of the rituals that you want to do. Hopefully, it is not Ship 25. Please, not Ship 25. We don't want to roll back of Ship 25. That would be ideal.
All right, so we'll have to keep an eye on seeing exactly what it is they roll out. And we know that they're closing the road and they intend to roll something. And what's great is that we are also interested in this, that we will find out what it is and bring it to you when it occurs. We've got cameras that you can watch all day long and all evening long. And of course, as we were just seeing some of the chat about what time the Starlink is going off tonight, it is a little bit later in some parts of the world than just the evening. So if you're up for a really late night, depending on where you are in the world, we'll be here to keep you company. And we've got our night crew that will help do that for you. So that is going to do it for this edition of Countdown to Launch. Trevor, any last words before we head out?
Let's just hope that Ship 25 isn't shipped to the production site.
That's right. We don't want it to go back. We want it to stay out there, right, Alex?
Mm-hmm. Stay at the launch site, because a rollback to the production site will be bad news, I think.
It will be. It will be. And you know what? Either way, we'll have lots to talk about, and we'll all gather here to share our thoughts and ideas. So thank you, everyone who watched today, all of you who chatted with us. Thank you very much. And we'll be back again with another edition of Countdown to Launch, along with our other coverage coming up very soon. Thanks for watching.